Welcome back to Live Now from Fox. I'm Keith Landry. It's 8:30 on the East Coast. It's 5:30 on the West Coast. We are continuing that news conference now with NASA and what they learned early this morning when the Boeing-built Starliner capsule landed in the New Mexico desert. We've been listening to the debriefing. They are taking reporter questions now. Let's listen in again.
Perhaps was not opening for some reason. So we'll have to take that thruster off the vehicle when we get it back to the C-3PF. Send it back to the vendor for some analysis, and then we'll know more about what the fixes are for that as well.
Okay, now we are going to go to David Curley with Full Throttle.
You've talked to Steve in the past about, what do we do about the vehicle? Is it changing some of the materials in the thrusters? Is it redesigning the doghouse? I know you have a lot to learn still, and so does Boeing, but how much work do you think is actually ahead? Is it just using a computer to tell the thrusters to fire in a certain way as you did on reentry today to change their performance? What do you actually think you'll have to do?
Yeah, that's a good question, and we have again several teams off looking at that. What we would like to do is try not to change the thruster. I think that is the best path. The thrusters have shown resilience and have shown that they perform well as long as we keep their temperatures down and don't fire them in a manner that causes the temperatures to go up, that then causes either the vaporization of the oxidizer, which causes low thrust, or the poppet swells. Today, obviously, the thrusters had all recovered at station. And obviously, it looked like today we didn't have those high temperatures. We knew that the downhill phase would be a little less demanding on the thruster than the uphill phase. What we need to do now is go take a thruster at White Sands and make sure we understand the exact pulse sequences that caused the heating. And then, at the same time, in parallel, look at software changes to reduce the number of demands on the thrusters. And then, in parallel with that, look at the doghouses and see if we can, again, they're trapping a bunch of heat. We know that when we fire the thrusters, the doghouses are trapping heat. Can we go make some changes to the blankets and the inside of the doghouses to keep the thrusters cooler? So it's really three different thrusts, I would say.
Okay, next up we have Jonathan Woods with Working Tins.
Hey, thanks for your time this morning. Reflecting back on the question that was asked about the successful failure with Apollo 13, if we think back about 2020 when Crew Dragon Demo 2 launched, I think the most significant issue that we faced during that mission was launch scrub due to thunderstorms during it was Tropical Storm Bertha. Thinking about that, when we say this mission is a success, how do we position this versus the relative success of a 60-odd day mission with Demo 2 compared to the insurmountable challenges, the testing, and everything that had to transpire to make the difficult decision to keep crew on board station for a very long duration mission?
Yeah, I'll take it and see if Joel has anything to add. When I look back at Demo 2, Demo 2 was very clean in flight. However, I think a lot of people forget that after landing, we discovered there's a device called a tension tie that goes in between the Dragon spacecraft and the trunk that attaches the two together. And there's a very complicated thermal protection system closeout around those tension ties. We found out after the flight that we had some erosion around that thermal protection system area, and we had to go change the design in between Demo 2 and Crew 1. We made some substantial changes to that closeout and then went and flew. So Demo 2 had its challenges as well. I think every test flight has its challenges. What we see with Starliner is a very robust spacecraft, but yet we have some challenges with the thrusters that we've got to go attack and move forward and fix. I wouldn't call them insurmountable. I think, what we've seen out of the Boeing and NASA team is a resilience and able to overcome challenges, and we just need a little time to go work through it. I think we learned a ton during this flight, which is invaluable moving forward to Starliner 1. Now we just need to take that learning and make some changes to the system so that we don't overheat the thrusters, and I'll see if Joel has anything to add.
Yeah, the only thing I'll add is, the lessons learned that we have on these demo missions play forward to other future missions. The question was asked earlier, do you think the programs, the commercial programs have been a success? And yes, these lessons learned that we're able to take from both the Boeing mission and from the Dragon missions are lessons that we are carrying forward for future missions and future providers, such that we can continue to develop the low Earth orbit commercial.
I would just add that it's really hard to compare the Demo 2 mission to this mission. Keep in mind that we took a different path with the Dragon vehicles. We developed cargo capability first. So by and large, things like dealing with prop systems and a lot of the things that we're now learning with the screwed flight test were dealt with during the cargo era. And then we upgraded the vehicle for crew. So very different development paths between the two spacecraft.
That's a really good point.
Thank you. Okay, next we're going to hear from Mike Wall with, I'm sorry, it disappeared, but Mike Wall.
Yeah, hi. I'm with Space.com, actually. Thank you for taking my question. I just wanted to say, first of all, congratulations on a successful landing. And second, I was just wondering if you heard anything more from Butch and Sunny, just kind of how they're feeling today, what their reactions were to the landing, and just how they're feeling about, the next few months that they'll be spending on orbit. Thanks.
I haven't spoken to them today. Obviously, today was really busy. They were on board doing a lot of work for us. They did wish the vehicle well and best wishes for the landing. And of course, they watched it the whole evening. So no updates from what I reported before. After station's always busy. I know I always tell you guys that, but after Starliner departed, they were off working on other activities for us. So right away, they jumped into some other work. So no other updates from what I've reported to you previously.
Okay, and we've got one more question on the phone bridge from Sophie Sanchez with Cosmic Chicago.
Hi, thank you for taking my call. I had a question about the failed thrusters that were mentioned. Was the redundant thruster that you mentioned part of the same system? And just a hypothetical question, I guess, if that had failed, what would have been next? And what could have happened if they both failed? Thank you.
Yeah, we did have a redundant thruster available on the crew module to do the function that we needed. We did need that thruster to work during all of entry, so I wouldn't say all of entry, but through the highest part of entry to a certain phase. If that thruster would have failed, it would have been acceptable. But once we got off the separated from the service module, we no longer have those thrusters. So the one remaining upfiring thruster worked just fine. We'll go back and understand what happened with the CTU-2 thruster that failed, and we'll go solve that problem and move forward.
Okay, we did have one more question come in from Kenneth Chang with the New York Times.
Yeah, hi, thank you. This is for Steve Stitch. So during this news conference, you've outlined a bunch of work that you need to do, especially with the thrusters and the dog houses. In the past, you've also mentioned that it's really hard to test the dog houses on the ground because getting the whole system to mimic what you see in space. How will you be able to get enough data through simulations and through testing that you have the confidence for Starliner 1 without flying another test flight?
Yeah, that's a great question. We're going to take the data from this flight and work to build models on the ground, and then we're also going to look at, is there a way to test what I would call an integrated doghouse on the ground in a vacuum chamber. We've got some ideas of maybe how to do that. At White Sands, we'll put a team together to see if we can actually put it in a chamber and fire the OMAX and the other thrusters and get that data in that environment and then, extrapolate that data to the orbit vehicle. So there may be a way. We just need a little bit of time to work through that.
Right. Well, I think that is our last question, so we will wrap up there. Thank you so much to our briefers for sticking with us through a late night. We really appreciate it. And thanks to all of you for following along.
Okay, we were watching together as NASA gave a briefing on the Starliner capsule built by Boeing, detaching from the ISS very early this morning, and a 6-hour mission back to Earth, where it landed very early this morning in the desert sands of New Mexico. Lots to learn now, lots of data, lots of observations, and the Boeing team and the NASA team, the engineers will work together to figure out how to fix those thruster issues and the helium leaks that plagued that mission on the way up. It was a 8-day test mission, Boeing's first test mission with 2 astronauts on board. They had problems on the way up. They had problems docking. An 8-day mission for the astronauts has now turned into an 8-month mission, and they'll catch a ride back to Earth in February from a SpaceX Dragon capsule. So disappointment for Boeing. NASA making the judgment call that in the end they thought it was still a little too risky to put the 2 astronauts back on that Starliner capsule, so it flew back empty last night. A couple of space suits, some old equipment from the ISS. Lots to learn still. We're going to take a quick break. When we come back, with less than 2 months until the November 5th election, we'll tell you what's going on as the race heats up when we come back.